So good morning, welcome to EduMath Zone. So we have been discussing 10th standard mathematics, that is chapter sets. It is specially the public examination revision series. So far we have discussed 24 questions. Today we discuss 25th questions onwards. So let me discuss the 25th question. Please all of you look at the screen. 25th question. If A equals to 1, 2, 3, 4, 5 and B equals to 2, 4, 6, 8, then find n of A union B. Find n of A union B. So welcome all of you, welcome. So that means first of all, n of A union B means cardinality of A union B need to be evaluated. So before going to find out cardinality of A union B, so it is necessary to find out A union B first. After that, count the number of elements present in the set A union B. So that gives us our answer n of A union B. So first let us move to first given data write down. That's important. Given data. So here A equals to 1, 2, 3, 4, 5 and B equals to we have 2, 4, 6, 8. So first let us find out A union B. So A union B is equal to union of the set A 1, 2, 3, 4, 5 union 2, 4, 6, 8. So now this equals to we can write 1, 2 repeats 2, 3, 4 repeats take one time only 5, 6, 8. This is A union B. It's very simple. Here we are asked n of A union B, number of elements present in set A union B. 1, 2, 3, 4, 5, 6, 7. 7 is not there. 1, 2, 3, 4, 5, 6, 7. So therefore the cardinality of A union B or cardinal number of A union B, n of A union B is equal to 7. This is the answer. So now shall I move to the next question? 26th question. The 26th question now. Write the relation between among n of A, n of B, n of A intersection B and n of A union B. So now we need to establish a relation among n of A, number of elements in A, number of elements in B, number of elements in A intersection B and number of elements in A union B. So we need to establish a relation among these four. So let assume that A comma B be any two sets. So this can be performed with the help of the Venn diagram easily. So first this is the mu rectangle for mu, universal set. Here take set A, different color, take green color B, suppose see this is actually red color is n of A part, n of A. So here n of A, this will be n of A intersection, this is A intersection B part, this is A intersection B part. Okay, now how to write the n of A union B is equal to n of A union B is equal to n of A plus n of B minus n of A intersection B you will be getting. So that means this will be combination. So clubbing A union B means actually here A, this is actually A minus B, this part is A minus B, this part is A intersection B, this part is B minus A. Generally here A union B is equal to, we can write like this, A minus B union A intersection B union B minus A we can write. Suppose n of A union B equals to, we can write n of A minus B plus n of A intersection B plus n of B intersection A. But very clear, n of A intersection B means very simple, we can write n of A minus n of A intersection B. So that means we can write n of A union B is equal to n of A minus B means minus n of A intersection B plus n of A intersection B plus n of B minus A is equal to n of B minus n of A intersection B. You see very clear, minus n of A intersection B plus n of A intersection B cancel. We have n of A plus n of B minus n of A intersection B. So this is the relation among n of A union B, n of A, n of B and n of A intersection B. And one more interesting factor also, here n of A is equal, n of A minus B is equal to n of A minus n of A intersection B we can write. N of B is equal to, sorry, n of B minus A is equal to n of B minus n of A intersection B also we can write it. So this is the relation. So therefore hereafter you remember n of A union B equals to n of A plus n of B minus n of A intersection B. So this is the relation. And one more important note, write down, important note. First point, let A comma B be any two sets, then first point, n of A minus B equals to n of A minus n of A intersection B. Second point, n of B minus A equals to n of B minus n of A intersection B. And third, n of A union B equals to n of A minus B plus n of A intersection B plus n of B minus A. So very important formula now we are going to write. That formula is fourth formula. So from these three we can establish this important result. You remember n of A union B is equal to n of A plus n of B minus n of A intersection B. Or we can write like this, n of A intersection B equals to, bring minus n of A intersection B this side, n of union B this side. So what do we get? N of A plus n of B minus n of A union B. So please remember these important points. It will be useful for different entrance examinations also. Now the 27th question. 27th question. 27th. If A and B are disjoint sets, disjoint sets, then find n of A union B. N of A union B. So if A and B are disjoint sets, then find n of A union B. So first we need to define what is meant by the disjoint sets. So after defining the disjoint sets, we are able to write n of A union B. N of A union B is equal to, we can make use of the relationship among n of A, n of B and n of A intersection B. So here see, first the concept of the disjoint sets. So let me explain the disjoint sets. See, if A intersection B is equal to nothing, null set, void set, empty set, pi, then A comma B are said to be disjoint. Said to be disjoint sets. So my dear students, you can note it down. So you can remember also. And moreover, n of A intersection B. In this case, number of elements present in A intersection B. N of pi. N of pi means no element. So 0. N of A intersection B becomes 0. So that means here, using this keyword disjoint sets, here we can write n of A intersection B is equal to 0. As we know the n of A intersection B 0, now we can define n of A union B. So now the solution, given data, A and B are disjoint sets. So that is A intersection B equals to pi, null set. So now we need to find out, our destination is this one, our target. Now n of A union B. Using formula, what is n of A union B? N of A plus n of B minus n of A intersection B. So now this we can write n of A plus n of B minus n of pi. A intersection B means n of pi is equal to 0. So what do we write? N of A plus n of B minus 0. So n of A plus n of B minus 0 means we get n of A plus n of B. Very simple. If A comma B are disjoint, n of A union B is equal to n of A plus n of B. N of A plus n of B. So it has been formulated in such a manner. Twenty-eight question. If A equals to 1, 2, 3, 4, 5, 6, 7, 8 and B is equal to 4, 5, 6, 7, 8, then find n of A, number of elements present in A, n of B, n of A intersection B, comma n of A union B. Using relation among them. Among them means using the relation n of A, n of B, n of A intersection B, n of A union B, using the relation among them. So that means better you write, change the question like this. Find n of A, n of B, n of A intersection B, and also n of A union B using relation among them. This is the question. Question ought to be like this. Right. So how to proceed here? Very simple manner we can. First of all, you need to find out A union B and A intersection B. After that, write down n of A, n of B, and n of A intersection B. Otherwise, just simple. Find A intersection B. N of A write down, n of B write down, n of A intersection B write down, n of A union B formula write down, and evaluate n of A union B. Okay, let us proceed. Let us proceed for the solution. So given data, A equals to 1, 2, 3, 4, 5, 6, 7, 8. B equals to 4, 5, 6, 7, 8. So first let us find out A intersection B. 1, 2, 3, 4, 5, 6, 7, 8. Intersection 4, 5, 6, 7, 8. So what are the common elements here? 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. So this equals to, we can write 4, 5, 6, 7, 8. Now we know A, B and A intersection B. So now let us write first of all n of A. N of A equals to, here 1, 2, 3, 4, 5, 6, 7, 8. N of A is equal to 8 elements are there. N of B, see 1, 2, 3, 4, 5 elements are there. N of A intersection B. In N of A intersection B, we have how many elements? 1, 2, 3, 4, 5 elements are there. So now we need to find out N of A union B. So what does formula state here? Formula states that N of A union B is equal to N of A plus N of B minus N of A intersection B. So let us replace the respective values of N of A, N of B and N of A intersection B. See, N of A is equal to 8, N of B is equal to 5. So that is 8 plus 5 and minus 5. So here 8 plus 0, you will get 8. So in this way we can find out. Right. So now the 29th question. Draw Venn diagram for a subset of big So this is the symbol for subset of. You need to read subset of, subset of, subset of. So we need to draw the Venn diagram. So Venn diagram means solution, you see. First rectangle, this mu. A subset of B means B contains A, or actually A contains A, or A is contained in B. A is contained in B. So that means first is the superset. First B is the superset right now. In that A will be the subset. So you will be getting A. This is the figure for Venn diagram for A subset of B. A subset of B. And one more note write down here, very important note, first point. If A is subset of B, then A intersection B. You check from the figure, A intersection B means common of both A comma B is A set A itself only, A. Second important point, if A is subset of B, then A union B. A union B means if you shade like this, what happens now? You will get B. So these are the important observations that can be made from this Venn diagram. Okay, now the 30th question. Write the set builder forms for first A union B, second A intersection B, third A minus B, fourth B minus A, fifth A minus B union B minus A. So you are asked to write the set builder forms also. So let me write one by one set builder form. So first one, solution, first one. Set builder form for A union B. A union B means like this, you start like this. X such that X belongs to, the symbol is belongs to A, or X belongs to B. This is the set builder form for A union B. Second, set builder form for A intersection B. That is X such that X belongs to A and, not R symbol, and X belongs to B, both A and B. Next, third one, set builder form of A minus B, that equals to X such that X belongs to A only and X does not belongs to B. This is symbol does not belongs to B. Does not belongs to B. Now you can expect B minus A. So B minus A equals to X such that X belongs to B only but not A, and X does not belongs to A. Next, fifth one, A minus B union B minus A. Actually, the A minus B, B minus A is called symmetric difference between A and B, but you may be studied in higher classes, don't worry. This we need to write X such that X belongs to A union B, but X does not belongs to the part of A intersection B. This is the set builder forms for these five. These five are very important for even all competitive entrance examinations. And one more note you remember, A minus B union B minus A equal to A union B minus A intersection B. This is also correct. This statement is also correct statement. Now 4 marks problems. 4 marks. See, 31st problem. If A equals to X such that X belongs to N, natural number, and X is a factor of 6, B is equal to X such that X belongs to N, natural number, and X less than 5. C equals to X such that X belongs to whole number and X less than 7. So then find first point A union B, second A intersection B, third A minus B union C, fourth A minus B intersection A minus C, A minus B intersection A minus C. So in order to solve these questions, first of all, 4 marks questions, read question very carefully. Given data, write down. In given data, actually, first of all, if you observe from here to here, all these 3 sets are given in set builder form. So they need to be addressed or they need to be written in roster form. So after putting them into the roster form, first try to find out all the values. A intersection B you are asked, A intersection B, and A minus of B union C. Regarding to this third question, first we need to find out B union C. After that, B union C should be subtracted from the set A. That the difference of the two sets. So whereas in the fourth question, you need to find out A minus B as well as A minus C. Then they need to be, we need to find out intersection of A minus B and A minus C. So now let us try a solution. So given data, in the given data directly we can write A equals to roster form also we can write X is the natural number factor of 6. Factor of 6 means 1, 2, 3. So B equals to natural number less than 5. 1, 2, 3, 4, 5. C is a whole number and less than 7. 0, 1, 2, 3, 4, 5, 6. So this is the given data. It gives the 1 mark in the examination or sometimes 2 marks. So now let us go for first question. First question is what we have. A union B we need to find out. A union B. So now set A. What is set A? 1, 2, 3. Union set B. What is set B? Set B is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So can you list out now in a chart box? What is the answer? You may get it. Expected answer. 1 2 3 1 2 3 repetition, so you get 1 2 3 4 5. 1 2 3 4 5. Here interesting is think that here 1 2 3 4 5 is same as B, so we can write even B also equals to B. This is observation. We can make observation. We can have the observation. Second question is A intersection B. So A intersection B means here A is 1 2 3 and intersection 1 2 3 4 5. So common elements of both the two sets need to be written here. So what are the common elements here? 1 2 3 1 2 3. Just common elements right now. 1 comma 2 comma 3. But 1 comma 2 comma 3 is nothing but A here in this case. So as far as the third question is concerned, so third question, first B union C find out. Third question. So first B union C. What is B? B is 1 2 3 4 5 union C. What are the elements in C? 0 1 2 3 4 5 6. 0 1 2 3 4 5 6. So now if you just club all the elements, you get 0 1 2 3 4 5 6. This is B union C. But what we need to do it? We need to find out A minus B union C. A minus B union C. What is set A? Set A is 1 2 3 minus 0 1 2 3 4 5 6. See here 1 1 cancel, 2 2 cancel, 3 3 cancel, even 0 4 5 6, nothing remains. So what do we get? No element. This is called pi. Say equation 1 this is. Next, go to the next question. What we have next question here? See, A minus B intersection A minus C. First A minus B find out. A minus B we need to find out. So next question, that is fourth question. First we need to find out A minus B. What is A minus B? A is 1 comma 2 comma 3 minus set B. What is set B? Set B is 1 2 3 4 5. 1 2 3 4 5. So now here what happens now? 1 1 cancel, 2 2 cancel, 3 3 cancel, even 4 5 also. So here nothing will remain. This is also null set pi. So now A minus C also we need to find out. A minus C. A is 1 2 3. Set C. Set C is equal to set C 0 1 2 3 4 5 6. So 1 1 cancel, 2 2 cancel, 3 3 cancel, even 0 4 5 6 elements will be cancelled. This is pi. But what we need to do? A minus B intersection A minus C. So pi intersection pi. Pi intersection pi is equal to pi only. You get pi. This is 2. What we observe? Therefore, we observe that A minus of B union C is equal to A minus B intersection and A minus C. This can be established. Right. Second problem. Write the write the elements in the sets A and B, in the sets A and B from the following Venn diagram and verify n of A union B plus n of A intersection B equal to n of A plus n of B. So first, all of you, my request is that please read the question and understand the question. That's very important. First of all, first let me draw the Venn diagram here. This is the Venn diagram. So even you are able to read the Venn diagram very carefully. That's very important criteria. So first, this is the set A. This is set B. Say A, this is B. Now elements write down 3, 5, 2, 4, 6, 1, 7, something 9. Okay, leave it now. So now from write the elements in set A, set B by reading this figure, by visualizing this figure, and verify n of A union B plus n of A intersection B is equal to n of A plus n of B. This it needs to be verified now. Solution, first let us write here A equals to means this total blue circle, the elements which are lie in the blue circle, 2, 4, 6, 3, 5. So that we can write 2, 3, 4, 5, 6. This is set A. Set B also write down. Set B is other color, that is 1, 3, 5, 7. So now with this, actually we can write even A union B also we can write, A intersection B is also we can write. A intersection B is equal to both combination, blue color and this color, that will be 3, 5. And even we can write A union B also. A union B is equal to 1, 2, 3, 4, 5, 6, 7. Now you need to verify this one. You need to verify. So in order to verify, we have here, so we have n of A write down, n of B write down, n of A intersection B write down, and n of A union B write down. So let us go to the previous page once again. N of A. How many number of elements are there? 1, 2, 3, 4, 5. 5 elements. So this is 5. Now N of B. N of B means how many number of elements? 1, 2, 3, 4. 4 elements are there. So 4 elements. N of A intersection B. N of A intersection B means here 2 elements are there. 2 elements. So 2 elements. N of A union B. N of A union B is equal to 1, 2, 3, 4, 5, 6, 7. 7 elements. So now we need to check like this. Take LHS. LHS is equal to N of A intersection B plus N of A union B. So that equals to 2 plus 7, whose value is 9. Now RHS, right hand side. Right hand side is N of A plus N of B. So that equals to 5 plus 4. Now what do we observe? 9 equals to 9. Here LHS equals to RHS. Hence, or therefore, N of A union B plus N of A intersection B equals to N of A plus N of B. Therefore, it is verified. It is verified. So, understood or not? Yes or no? Understood or not? Yes or no? Third question. 33rd question. 33rd question. From the following Venn diagram, from the following Venn diagram, verify N of A union B equals to N of A plus N of B minus N of A intersection B. So from the following Venn diagram, you need to verify N of A union B is equal to N of A plus N of B minus N of A intersection B. So first you need to verify. Okay, this is the Venn diagram. Set A this is. So this is set B. Set A, set B. So what are the elements given? 1, 4, 5, 6, 2, 3, 7, 8, 9, 10, 11 and 12 and 14. Right. So what shall we do now here? So in order to verify this relation N of A union B is equal to N of A plus N of B minus N of A intersection B, first of all in the given data, write down elements in A, elements in B with the help of the Venn diagram. That means by reading the Venn diagram, by understanding the Venn diagram or by visualizing the Venn diagram. You need to write A, B, after that find A intersection B and A union B, and after that just start for the verification of the formula. So now the solution. Here given data, A equals to, what are the elements present in the A? A equal to 1, you can write 3, 4, 5, 6, 7. So now in B, what are the elements present in B? That is equal to 2, 3, 7, 8, 9, 10, 11. Now A intersection B, common part of both, that is this part, 2, 3, 7. So 2, 3, 7. Now A union B also we can write. A union B equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's all. But 12, 14 do not belong to either A or B. You remember like that. So now we need to write n of A, number of elements present in A, 7 elements. N of B, you count them. 1, 2, 3, 4, 5, 6, 7. N of B is also 7. N of A intersection B. Count the elements that are present in A intersection B. 3 elements. Now count N of A union B. So that equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So now first this is left hand side, this is right hand side. Verification has to be done now. That will be proceeded, that step. So now left hand side, N of A union B. N of A union B equals to, so how many elements are there? 11. So this is 11. Say equation 1. Now right hand side. Right hand side is N of A plus N of B minus N of A intersection B. So that equals to, what is N of A? N of A is equal to 7. N of A is equal to 7. N of B is also 7. So N of A intersection B is 3 elements we have. 3. So 7 plus 7 is 14. 14 minus 3 is 11. Say equation 2. So from 1 and 2, we have LHS equals to RHS. So therefore, N of A union B equals to N of A plus N of B minus N of A intersection B. Hence, it is verified or checked. So tomorrow we shall meet you by 5:10 a.m. Thank you. Bye bye. I hope you might have enjoyed. So tomorrow also this chapter will be continued. Still few more questions are left. So that will be discussed. You have any doubt also, you can ask in the offline session. Then I will address tomorrow. Thank you. Bye bye.